Okay, getting ready for the STAAR test. Here we have TEK A-5C, which is about solving systems of linear equations. There are two main types of questions in this category. One's where you're given a word problem and you have to write your own equations, and then ones where you are given the system of equations outright. We'll start with these first. There are three ways to solve these type of problems. You can solve them by graphing, you can solve them by substitution, or you could solve them by elimination. Anytime you're given what one of the variables is equal to, x is equal to whatever, you're going to want to end up using substitution. It's an easy fit. We now know what x is, so we plug it in for the x. So we'll write 7, but instead of the x, we put parentheses and put what we know it is, 2y minus 4 plus 5y is equal to negative 66. And now we just continue to solve it. 7 times 2 is 14y. 7 times negative 4, we have to distribute to both things inside the parentheses, is negative 28 plus 5y is equal to negative 66. We see like terms, so we need to combine them. 14y and 5y is 19y. Minus 28 is equal to negative 66. We have to add 28 to get rid of it so we can get the y on its own. Plus 28 is equal to negative 38. The 28's are gone. 19y is equal to, the last step, we want to divide by 19 to get rid of the coefficient. Y is equal to negative 2. Now, if you are a sloppy student, you're going to see a negative 2, you're going to see a negative 2, and you're just going to pick it. But you know we are solving a system of equations, so we're looking for an ordered pair. And so this is the y value of that ordered pair. And in this question specifically, we're looking for the x value of the ordered pair, which we haven't found yet. We need to substitute, now that we know what the y value is, we substitute that back into one of the two equations. And of course, we're going to pick the first equation in this case because it tells us x is equal to, and that's what we're looking for. So x is equal to 2, but instead of the y, we now know what it is, so we put parentheses, negative 2, and then minus 4 to finish that first equation. X is equal to, and 2 times negative 2 is negative 4, minus 4, x is equal to negative 8. We know that x is equal to negative 8, h. So if the question had asked for the whole ordered pair, it'd be negative 8, comma, negative 2, the x and then the y. We'll solve another question where they've given us the equations. In this case, we see this time they gave us what y is equal to. Y is equal to that. So we're going to plug that in for our y value. 1/2 x plus 4 is equal plus. So that was this entire part where the y is, and now we continue the equation. Plus 2x equals negative 1. Even though I wrote those parentheses, we don't need them. It would be like there's a 1 in front, and you distribute the 1 and nothing changes, so they're unnecessary. We have 1/2 x and 2x, so we can combine like terms. That would be 2.5x plus 4 is equal to negative 1. We want the x on its own. Minus 4 minus 4. 2.5x is equal to negative 5. Divide by 2.5. Divide by 2.5. X is equal to, negative divided by a positive is negative, and we know 2.5 is half of 5. So the answer is negative 2. I could stop there because we solved for what the x was, and it asked us for the x value. If it had asked us for the y value, we would have then had to take this number, plug it back into the x value, and then solve for y. We just didn't have to in this problem. Here's another problem where they've given us both equations. We see that y is equal to this, so we're going to substitute it in, 10x minus y, but in this case we know what y is, negative 13x plus 92 over 2, and then we continue the equation, equals 53. We can go ahead and distribute this negative and divide both of them at the same time here. We've got 10x. This negative is going to cancel out with the negative that's in front of the 13 and give us a positive number, and then it's 13 over 2, or 13 divided by 2, which would give us a positive 6.5x. And then this negative is distributed to the 92, which will give us a negative 46 equals 53. We need to combine like terms. We have 10x and 6.5x giving us 16.5x minus 46 is equal to 53, plus 46 plus 46. 16.5x is equal to, we have 53 plus 46 gives us 99. And then the last step, divide by 16.5, divide by 16.5. X is equal to 99 divided by 16.5. We can grab our calculator. 99 divided by 16.5 is equal to 6. So now we know our x value is 6. Now in this case, when we look at our answer choices, all the x values, A is the only one that has the correct x value. So we don't need to do the second part, which would be plug this back in for our x and solve for y. Alright, we have two more that were given to us. We see that we know what y is equal to, so we're going to plug that in for our y. 3x is equal to 2 parentheses negative 6x plus 18 plus 14. Distribute. 3x is equal to negative 12x plus 36 plus 14. We have like terms here, two regular numbers, so we're going to add 36 and 14, which will end up giving us 50. Bring everything else down. Negative 12x, 3x. We have x's on both sides. We want to get them to the opposite side. We'll get rid of this negative 12x by adding 12x. There should be a plus there. The 12x's are gone. We have 15x is equal to 50. We're going to end up dividing by 15, dividing by 15. X is equal to, and we know that the 50 and the 15 can both be divided by 5, which leaves us with 10 over 3. The answer is A. Since it asks for the value of x and we solved for x, we don't need to plug this value back in for our x and solve for y. Alright. Here we are not given, unlike the previous problems where we have y equals and we're given what y was equal to or what x was equal to, we are now given two equations in standard form. In this case, we're typically going to try and use elimination. So we're going to try and compare the x's and the y's and see if we can multiply by anything to get them to cancel. And we see we could turn a 4 into a 12 and get the 4 to cancel. We could also turn a 7 into a 21 and get those to cancel. So it's really our own preference. Let's go ahead and just cancel the x's. What can we multiply by 4 to get it to cancel with a positive 12? Well, we would want to multiply by negative 3 so that when we multiply times 4, we would get a negative 12x to make it cancel. So that's what we'll multiply by. We have to multiply it by everything in the parentheses. So negative 3 times negative 7 would give us a positive 21y. Negative 3 times negative 2 would give us a positive 6. Now, in this case, when we try and combine them, we see the 12x's cancel. We have 0. The negative 21 and the positive 21 cancel, so we have 0. We're left with 0 is equal to negative 36. Now, this is an odd situation for a lot of students to come upon when all the letters cancel. It's unusual, but that does not mean we're wrong. It means it's one of the two scenarios for a system. Either the lines are parallel and they never touch, so there's no solution, or the two lines are directly on top of each other, one line and the other line, so they are always hitting each other, in which case there are infinitely many solutions. So which would it be in this situation? Well, we look at the solution we got. Is 0 equal to 36? And the answer to that is no, it's not. So there is no solution to this question. Now, for all of these questions that we've just solved by hand, which is what a skill that you need to have, remember that you can also use the calculator and type in menu 3 for algebra and then 2 for systems, and then type in the work. Let's do this one as an example. We're going to type menu 3 for algebra, 2 for solving systems. We're going to click OK because there are two equations, and we're going to use x and y. And now we simply type in the equations the way we see them. X is equal to 2y minus 4. Then we hit down arrow to go to the second equation. 7x plus 5y is equal to negative 66. Hit enter. And there we see that it gave us negative 8, negative 2, which was exactly the same answer that we got here. So all of those problems for the last 13 minutes that we've been working, for each one we could have typed in menu 3, 2 and gotten our answer relatively quickly. Now for the last part, let's work on the questions where we have to write our own inequalities, or own system of equations I should say. Two customers went to a post office to buy postcards and envelopes. Each postcard costs the same amount and each large envelope costs the same amount. So here's our first equation. The first customer paid $12 for 14 postcards and 5 large envelopes. The second customer paid $24 for 10 postcards and 15 large envelopes. What was the cost in dollars? Well, for this first customer, we see that they paid $12. That was the total, so we'll put $12 there. And they spent 14 postcards. They bought 14 postcards. Well, what letter do we want to give for postcards? We could call it P. Let's go ahead and just call postcards X and envelopes Y. So it was 14 postcards, 14X. And he also bought 5 of the large envelopes, which we've called Y. So there's our first equation. Not too bad. Second equation, we have our total of $24.80. And then 10 postcards, 10X, plus 15 envelopes, 15Y. So there are two equations. Now we could solve it by elimination. multiplying by -3 to try and get the 15s. -3 times 5 would give us -15, and that would cancel. We could solve it by hand, or you could solve it by doing menu 3, 2, and typing it in and getting that your answer is A. Since I've worked through so many of these questions, I'm going to just be setting up these word problems, and you can check your work and make sure it matches with the answer I've given. The other situation is talking about bus that's traveling two different routes, a green route and a blue route. On Monday, the bus traveled the green route 6 times and the blue route 5 times for a total of 52. Total of 52. The green route we'll call X, the blue route we'll call Y. So it's 6X plus 5Y. In the next equation, the bus traveled the green route 12 times, so that's 12X plus 13Y, which gives us a total of 119. And on this one, what might we multiply by so we can get elimination, since neither equation tells us what X or Y is? Well, hopefully you thought maybe you could multiply by -2, and then that would make your X's cancel, because you would have a -12X to cancel with that. But once again, you could solve it by menu 3, 2, and then typing in the equations. For our last couple of word problems, we have a manager purchasing a total of 21 coffee mugs and keychains each. So there's a total 21. Each coffee mug costs $8.50 and each keychain costs $2.75. If the manager spent a total of $132.50, that's another total, $132.50. So one is just talking about the total number of mugs or trinkets that we bought, mugs and keychains, and the other one's talking about the total value, how much each thing is worth. So this was just total number, and this is total value. So as we're writing our two equations, we keep separate which one is talking about just numbers. So we bought two different types of things, coffee mugs and then keychains. We'll call mugs X, keychains Y. So however many mugs we bought plus however many keychains we bought, that gave us just the total number. So there's the first equation. Then our second equation, it's however much the coffee mugs are worth, $8.50, times however many coffee mugs we bought, plus however much the keychains are worth, $2.75, times however many keychains we bought. So there's our second equation. And then using that system, we could solve by elimination or substitution, or menu 3, 2, and typing it in the calculator. Alright, for our last question, we have the wall inside of shoe store selling walking shoes and running shoes. There's a total of 135 on display. There are 1.5 times as many pairs of walking shoes as there are running shoes. How many pairs of walking and running shoes are there? Well, one of the totals was 135, and what is that a total of? Walking shoes and running shoes. So however many X plus Y we bought gives us the total number of shoes. Now, on the second one, we see there are 1.5 times as many pairs of walking as running shoes. So we're going to put our walking shoes, X, is equal to 1.5 times as many running shoes, Y. Let's double check, because that sentence can confuse students from time to time. There are 1.5 times as many walking shoes as running shoes. So which one are there more of? Well, walking shoes. There's more of those, 1.5 times as many walking shoes as there are running shoes. So the X is there. So that works. Those are the two equations. And once again, we could type menu 3, 2, and work our way through the problem. All right, that's TEK A.5C, solving systems.